Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 122 is on the screen. And yes, look at number 5, some pre-calculus stuff by now. Oh, yeah, it's starting to come in. Pour it in, Mr. Q. Oh, yeah, we got this. All right, so I'll give you guys some time. You should be able to do numbers 1, 2, 3, and 4. I'll go over number 5 as soon as we get there. Copy and go. All right, here we go for the sake of time. Number 1, it says rewrite each expression. 3 to the negative 2 is the same as 1 over 3 to the positive 2, which is 1 over 3 to the positive 2 is 9. So it's 1/9. By now that should have been a piece of cake. Number 1b, distribute the exponent to both numerator and denominator. This becomes 1 to the negative 3 over 3 to the negative 3. Since we can't have negative exponents, the numerator goes to the denominator and the denominator goes to the numerator. 1 to the third, 3 to the third. So this becomes 3 to the third is 27 over 1, which is 27, or 3 times 3 times 3. 1c, 3 to the square root of 5. Basically, they want us to rewrite it to its original. So question, before the 3, it became 3. What number came out of the square root to make it a 3? Tell your neighbor, what number was in the square root that became a 3 outside? What was that number? That is correct. A 9. Square root of 9 became a what? 3. So that goes back inside, and then we have a 5 inside. So what is 9 times 5? Square root of 45. That's what it was before. Number 2. 2 to the x minus 3 is the same as 2 to the x times 2 to the negative 3. Can we have negative exponents? No. 2 to the x over 2 to the positive 3 exponent. 2 to the x over 2 to the third is 8. All right. Number 3. 81 to the 1/2 exponent. 1/2 exponent is also known as square roots. Square root. So what is square root of 81? Oh, that is 9. Let's go with this one. 100 to the 1/2 exponent is what? Square root of what? 100, which is 10. I can go with plus minus 10. Right now I'm leaving it as a positive. But this one's a little bit different. 8 to the 2/3, I'm going to rewrite that. 8 to the 1/3 times 2. So let's circle this one. 8 to the 1/3, it's no longer squared because over here the denominator was a 2 for it squared. This is known as a cube root. Cube root of 8. Then at the end we take the exponent of 2. So what is cube root of 8? Well, what number times itself 3 times gives us 8? What number is that, everyone? Number is 2. 2 times 2 is 4 times 2 is 8. Bring down the exponent, so 2 to the second is 4. For number 4, just write, if you graphed it, that's fine. If not, we're going to leave that for the session because we are going to get into that. But let's go with number 5. All right. These are trigonometric functions. We're starting with sine, cosine, and tangent. Have you guys heard of those? Yes? All right. So what does that mean, Mr. Q? It means that sine, we're looking at opposite over hypotenuse, and these are our sides. Cosine is adjacent over a hypotenuse, and tangent is opposite over adjacent. So let's clarify some words. Here we go. These 3 only work with 90-degree triangles. So let me repeat that again. These 3 only work with what? 90-degree triangles. These 3 only work with what? 90-degree triangles. So in order to use 90-degree triangles, we need to know the terminology. I want you to highlight from A to B or B to A in green and label that. That is what we call a hypotenuse. That name doesn't change. That stays the same throughout your entire career with trigonometry or pre-calculus. Hypotenuse. All right. The other word that I need to clarify is this one, adjacent. Adjacent means next to, next to, next to. All right, so here they give us triangle A, B, and C. It's a right triangle. So if they ask me to find the sine, which is opposite over hypotenuse, that means that they want us to refer to a particular angle. What angle are they asking us to focus on? A. So then you get there, you circle angle A. Once you circle angle A, I'm going to write this so I can focus my attention on that angle. So in shorthand, I write sine of angle A is equal to, and you're going to write opposite over hypotenuse. So, here it goes. Imagine I'm standing over here. I'm focusing on this angle, and my view is that way. So here I am, looking at angle A, and I'm looking at the triangle that way. So question, which side is opposite to me? Is it 4, 5, or 3? Tell your neighbor which would be the opposite side of me. 4, 5, or 3? All right, let's go with Mario. Mario, which one? 3 is correct. That's opposite, so I would write 3 right there. And obviously, we know which one is a hypotenuse. Is that correct? So what would we write? 5. And that is what we call sine of A, 3/5. All right, let's try it again. Now we're going to focus on cosine. Cosine of angle A. And cosine of angle A says adjacent over hypotenuse. All right, once again, I'm here. What side is adjacent to me? Now, it can't be the hypotenuse because that name stays the same. So what other one is right next to me? Tell your neighbor, what side is right next to me? Mario, pass someone. Enrique. Bruh. Okay. What side is next to me when I'm standing over here? 4. Okay. So that's adjacent, and we know hypotenuse is 5, and that's how we find cosine of angle A. Let's go to tangent. Tan angle A. And that one we call opposite over adjacent. All right? So, look at it. Talk it to your neighbor. Let them know which side is opposite to me and which one is adjacent to me. And write your fraction. Mario, pass someone. Joseph. Which side is opposite? 3 is opposite, yes? Which one is adjacent? 4. Okay. Hands if you got that by yourself. All right. So, set that aside, please. That's how you do trigonometric functions. Here we go. We're done with warm-up 122. We're in the middle of moving on to exponential functions today. Brand new. We already finished with rationals last week. So those of you that were absent, make sure you come in during advisory to make up that block part tag. And tonight's home play is for transformations only. Okay, we good? All right, say hi to your neighbors for May. And go ahead and copy the home play code Write that down, please. EBGMR. 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 All right. Okay, good. So tonight's home plate, there it is. It'll pop up once you log in. All right, get a Cornell note ready, please. Our objective for today, I can graph and write exponential functions. We're moving on. I can graph and write exponential functions. I can graph and write exponential functions. All right, here we go. I can graph and write exponential functions. So in your Fourier model, get one ready. Exponential functions. Exponential functions. Exponential functions. Definition. A function written in the form f of x equals b to the x power. Or its transformation rule, g of x equals a times b to the x minus h plus k, where b has to be greater than 0 and b cannot equal to 1. And x is a variable. Examples. F of x equals 10 to the x. Does that look familiar? Yes, Mr. Q on the warm-ups. That is true. F of x equals 2 to the x. Same thing. G of x equals 5 times 2 to the x minus 3 plus 4. And g of x equals negative 2 times 3 to the x. All those are examples of exponential functions. Copy that. I'll give you some time. All right. So, let's see. I gave you a definition, and it says a function written in the form f of x equals b of x. So, I want you to underline the letter b and label it. That's what we know as a base. A base. So if we want to do that down here as well, the 10 is also a what? Base. The 2 is the base. 2 is the base, and 3 is the base. All those are bases. What else does the definition say? It says that x is a variable. X, circle the x, and that's known as the exponent. So what are we saying? That the exponent has to be a what? A variable. The exponent has to be a variable. The exponent has to be a variable. All right, there it is. Here it is. There it is. There it is. And there it is. So the exponent has to be a what? A variable. The base will always be a number. Notice here, 10, 2, 2, 3. But this is what they give us in the general rule. Okay? So now that we know what it is, look at these. Look at this one, and look at this one. Tell your neighbor why, first of all, why is this one not an exponential function? What is the first one not an exponential function? Talk to your neighbor. Why is the first one not an exponential function? All right. Pretty good. Let's go with someone that we haven't called on. How about Sean? Why do you think the first one is not an exponential function? Base is not a number. That is correct. Let's go. And also, what is the second thing, guys, that you guys notice? That the exponent is not a what? A variable. That is correct. Now, look at this one. Tell your neighbor why this second one is not an exponential function. Why is the second one not an exponential function? Why is it not? Sean, pass on one. Mario. Yeah, it doesn't have the function notation or the equal sign. That is correct. So, hashtags. It has to be a function. Hashtag function. Second hashtag. Base is a number, but not 1. And the third hashtag. Variable exponents. Yes, most definitely. That has to be true. All right. So, with that said, we good on exponential functions, what they are, yes? You, Lisa, we good? Yeah? All right. So, look up, please. Here's our general rule. Look up to the screen. Don't copy that. Revisiting our general rule. Tell your neighbor what k does to the entire function. What does k do to the entire function? Moves it in which direction? Renzo, k moves it in which direction? What is it? Up and down, that is correct. How about h? H moves it in which direction? Caesar? Left or right, that is correct. A stretches it or compresses it vertically. B stretches it and compresses it horizontally. Now let me show you the new rule. Look up. Copy that one, please. G of x equals A times B, x minus h, plus k. So once again, refresher. What does k do? Renzo said up and down. So you're going to draw a little arrow up and down right below the k. H moves it side to side according to Caesar. That is correct. A, compress or stretch vertically. And B, compress or stretch horizontally. So it pretty much does the same thing. The only thing now it looks a little bit different because now we're going to apply it to exponential functions. However, for exponential functions, k, I want you to circle it in red, serves a second purpose. And that is what we call HA. Remind your neighbor what HA stands for. Very good. Horizontal asymptote. HA, horizontal asymptote. And it should look like this. Horizontal asymptote. Okay, we good? All right. So, with that said, underneath that, you should have plenty of space. If not, start clean from the back side of your paper because we're going to need to graph and do transformations in there. So, in the back, example 1, copy these, please. I'll give you some time. Set up a coordinate plane from -5 to 5. No, -6 to 6, both on domain and range. Make sure you make it nice and neat, not with your feet, please. And the first f of x is in black. The second f of x, g of x, do that in green. And the third one in blue. So I'll give you guys some time. Ready, and all right. So that was plenty of time. So you should have your page that looks something like this. Yes. All right. So we're going to focus right now on our parent function f of x base 2 with exponent of x. So I'm going to zoom in here. Okay? So with that said, here we go. Let's fill up this table. So I'm going to take this, and I'm going to do my first substitution, which is negative 2 for x, yes? So I'm going to do f of negative 2 equals base 2 to the negative 2 exponent. Question, can we have negative exponents, guys? No, so we rewrite it to 1 over 2 to the positive 2. So that means, hold on, 2 on the denominator, 2 to the positive 2. So this is 1 over 2 to the second power is 4. So this is 1/4. All right, let's do the next one. F of negative 1 is base 2 to the negative 1 exponent. Since we can't have negative exponents, it's 1 over 2 to the positive 1. And anything to the 1 power is that same number, so this is only 1/2. 1/2. Next, f to the 0. 2 to the 0 exponent. Tell your neighbor what that is. Anything to the 0 exponent is? Anything to the 0 exponent is? 1. Bah. Been doing these on the warm-ups, people. Bah. Next, f to the 1 power. 2 to the 1 power. What did we say if it was to the 1 power? It's that same number, so the answer is 2. F to the 2 is 2 to the second. What is 2 to the second? 4. And last but not least, f of 3 is 2 to the third power, or in other words, 2 times 2 times 2, which is 8. All right. So, before, look up please, before we graph that, you wrote down your general rule. Is that correct? Yes, Mr. Q. Your general rule is g of x equals a times, parentheses, b to the x minus h plus k. Is that correct? All right. So, look up, please. Looking at this parent function through that question, we need an HA. Look at this, and look at this general rule. Tell your neighbor what the HA is. What is our HA? What is our HA, Joseph? 0, that is correct. He said 0. Why, Mr. Q? Well, because there's nothing after the 2 to the x exponent. Over here it says base plus the x exponent, and then there should be another number at the end. That would be our HA. Since it doesn't, it's 0. So with that said, let me zoom out. Let's graph our HA at 0. There it is. And now let's plot our points. Negative 2 1/4. Negative 2 1/4. Negative 1 1/2. 0 1. 1 2. 2 4. 3 8. 6 7 8. And what do you guys notice on this graph? We start very low, and then all of a sudden it goes what? quickly upward. That's what we call exponential functions. They increase, notice it increased exponentially. Students, exponential functions, students. All right. So now that we have our parent function f of x, label that f of x, let's go to the transformation, the first transformation in green. Look up, please. I'm focusing here. To get started, I need an HA. Tell your neighbor what the HA is for that one. What is our HA? Is there anything at the end? Talk to the neighbor. Is there anything at the end? All right, Joseph, pass someone. Mario, what is our HA for this one? Does it have anything at the end? No. Look at our general rule here. Look at our general rule. Here's the base. There's the X. There's the H. Does it have a K? Therefore, 0. So we already have that. Okay. So this, they're doing a transformation. So before we do that, look at the parent function. Here's our parent function. What's going to happen to this function according to this transformation? Talk it over your neighbor. What is that going to do? If that one is our h, what is that going to do to the entire function? Talk it over your neighbor. What is that going to do to the entire function? Mario, pass someone. Kelly. And just as Kelly's about to answer us, we know that K moves it up and down and H moves it side to side. Is that correct? All right, so that means this one's going to move it which direction, Kelly? To the right, how many steps? That is correct, 1 to the right. So all these points, let's start with, I'm going to start with this one. 1 to the right, this one, 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 1 to the right, and this one, 1 to the right. And we just did our first transformation. We're going to label that G of X. And we don't even need to fill in our table. From 1 to 5, I'll come to are you up to right there so far? Where are we at? 4, 5, 4, 5, okay. Let's switch to blue. Now we're focusing here. To graph this transformation, we need an HA. Look at it and tell your neighbor what our HA is. What is our HA? All right, good conversations. Kelly, pass someone. Mariah, what is our HA? Close. -5. That is correct. So let's go to -5 and sketch our HA. There it is. So if we start off with our parent function, f of x equals 2x, 2 to the x, which is this one, we're going to move this one according to this transformation. Talk about your neighbor. We're going to move all those black points according to that. Tell your neighbor, please. Mariah, pass someone. Ashlyn. Down 5, and then? And 1 to the right. That is correct. So, down 5 and 1 to the right. So we go 1, 2, 3, 4, 5, 1 to the right. This one, 1, 2, 3, 4, 5, 1 to the right. This one, 1, 2, 3, 4, 5, 1 to the right. 1, 2, 3, 4, 5, 1 to the right. 1, 2, 3, 4, 5, 1 to the right. 1, 2, 3, 4, 5, 1 to the right. And that's our new g of x. From 1 to 5, I'll come through. Are you with that so far? 4 5s, 4 5s. Okay. Not bad, not bad. All right. Next. Underneath that, I want you to write example mega Q. All right. So, f of x equals 2 to the x. All right. So if we have our table x, f of x, once again, we got -2, -1, 0, 1, 2. For the sake of time, we substitute -2 there. It's 1/4. This is 1/2. This is 1, 2, and 4. Okay, let's graph that. -2, 1/4. -1, 1/2. 0, 1. 1, 2. And 2, 4. Our HA is f of x equals 0. So, check this out. In blue, I want you to move these 5 points. Let's move them 4 steps to the right and 3 steps down. So, I take this one. 1, 2, 3, 4. 3 steps down. 1, 2, 3. So this point came over here. This one. 1, 2, 3, 4. 1, 2, 3. This one. 1, 2, 3, 4. 1, 2, 3. This one. 1, 2, 3, 4. 1, 2, 3. And this one. 1, 2, 3, 4. 1, 2, 3. Now we do need an HA, but before that, look up, write the function for this new one, please. Write it for that new one. Still base 2. We moved it 4 to the right, 3 down. All right, tell your neighbor what you wrote. G of x equals 2 to the what? We moved it 4 to the right, 3 down. Check with your neighbor. All right, Elijah, tell me what you write. 2 to the what? X to the what? -4. And then? -3. Hands if you got that. That is correct. However, we do need our what? HA, which is f of x, equals to what, everyone? Tell your neighbor what HA is according to this new one. Our HA is Enrique. -3. That is correct. 1, 2, 3. There it is. Let's do one more right there on the same one. I'm going to switch to green. This same black one, I want you to move, let's do 3 to the left and 2 up. 3 to the left, 2 up. The same black one, 3 to the left, 2 up. So, from here, 1, 2, 3, 2 up, 1, 2. This one, 1, 2, 3, 2 up, 1, 2. This one, 1, 2, 3, 1, 2. This one, 1, 2, 3, 1, 2. This one, 1, 2, 3, 1, 2. And write your new function, base 2. We moved it 3 to the left and 2 up. All right, show your neighbor your new function, All right, we got it? All right, let's see what you write for our new function. Base 2, what? Help me out. Annette, what you write? 2 to the what? X plus 3, parentheses, plus 2. Hands, have you got that? That is correct. That's how your home fleet's going to go. They're going to ask you to graph this one in all 4 quadrants, and then you write your function. From 1 to 5, we'll come to where you with this so far. 5 4s, 5 4s. Okay, we'll stop right there. Go ahead and log out, please. Those of you following on YouTube, make sure you put in some work for your transformations. See you guys next time. Peace.